Okay, so everyone can see the window okay? Let's see. Trying to minimize all of the Zoom nonsense. Okay. So, good morning. I am Daniel DuPont. This is Why Can't I Just Google It? Large language model web searches, the replication of viral misinformation and what to do about it. Because that's important, right? Doing something about it as well. You're welcome to screenshot the slides as we go, but I'll be sharing the entire slide deck and a resources page that will have everything I cite and the classroom activities that I share. So hello, again, I'm Daniel DuPont. I'm a librarian and associate professor at Delgado Community College in New Orleans. I'm the current president of the Louisiana chapter of ACRL. I'm researching AI accuracy in sycophancy and information retrieval. I have two cat children and one human child. My 2026 goal was to read 156 books this year. I've already read about 152 books since New Year's. This is not a flex. People are always like, oh my God, I can't believe it. I'm so jealous. No, this is unhealthy antisocial behavior. Do not be like me. And as we get moving into the presentation, I'm going to go ahead and turn off my camera because I have resting weirdo face. So let me do that real quick. There we go. Now I need to figure out how to get back to, there we go. Okay, back to the presentation. Words are hard. So let's define some vocabulary that I had to look up. So maybe you need to dictionary.com these words too. This one you probably know. I knew it. Of course, AI is artificial intelligence, computer systems that are programmed to process information like humans. Now we're getting into the ones that I really did have to Google. Gen AI is generative artificial intelligence. It's AI that uses generative statistical models, which means it predicts what's most likely to come next in a sequence. So here's a sentence broken up into its constituent parts, which are called tokens, and the AI predicts what's most likely to come next in the sequence using statistics. The AI uses statistics to generate content based on patterns it learned from training data, which is basically everything ever written and publicly available, and sometimes what's not publicly available. What is a GPT? I definitely had to look this one up. GPT, as in, yes, chat GPT. A GPT is a deep learning architecture used in chatbots that is pre-trained on large data sets and can generate new content. LLM. This is another one that I had heard used before, had no idea what it meant. An LLM is a model of the human brain's ability to process language trained on a large amount of text. The biggest and best are GPTs used in generative chatbots. We're going to talk later about what trained on a large amount of text actually means, so hang tight. And this one was brand new to me within the last month or so. If you've never heard of RAG, you are a very normal person who hasn't been diving into AI like a weirdo. Retrieval augmented generation, or RAG, is an information retrieval technique that allows an LLM to incorporate data from external data sources, supplementing its training data set before generating responses. If you see a chatbot say searching the internet or something like that before it responds, this is what's happening. It's doing a RAG query. That's especially important when prompts are about a recent event that occurred after the LLM's knowledge cutoff date. So after it went online, it might have a knowledge cutoff date of like January 2026. And if you're asking about something very recent, it might not have that information in its sort of database, in its memory. So the ethics of AI, y'all, I know. Without downplaying the very real ethical implications of AI, I want to briefly touch on them so we can move past the ethics to the information literacy issues. Algorithmic bias creates discriminatory outcomes that reflect systemic biases in the data used to teach the LLM. So garbage in, garbage out. The people who own the content used to teach LLMs do not receive any of the profits generated by GPT chatbots. Free or low-cost AI-generated content eliminates jobs in creative fields. Anthropic did a whoopsie. Anthropic, which is the company that created Claude, pirated thousands of copyrighted books. Now they have to pay out over $1.5 billion. This judgment was from almost a year ago. Claimants are still coming forward. I'm really sort of dialed into Bookstagram and book threads, so like authors and the book reader community. And this is a big deal that they pirated all these books and used it to train AI. And people are still talking about it. LLMs generate a large carbon footprint due to the power consumption necessary to run during training and queries. Training uses massive amounts of energy, and an AI query uses about 5 times as much energy as a regular internet search. Large amounts of fresh water are used to cool AI servers. You know how your laptop gets hot on your thighs? Imagine a giant building that's heating up like that. They have to cool those servers down, and they're using massive amounts of fresh water to do it. The mining and processing of rare earth minerals for microchips is environmentally destructive and produces toxic and radioactive waste. This disproportionately affects developing countries that don't participate in the benefits of AI. Okay, so let's talk about how viral misinformation gets created and how that's now being compounded by AI chatbots. So, avocados shouldn't exist. These are 2 clips from the educational YouTube channel SciShow, and I'm just realizing I'm not sure I told screen share to play sound, so we're going to make sure that it can play sound. Y'all are going to tell me if it doesn't play sound. Oops, went to the wrong one. Y'all are going to tell me if it doesn't play sound. If it doesn't, I will just summarize for you.
I don't hear it playing sound.
Sarah, did you say you could hear it?
I actually didn't hear it.
You didn't hear it? Okay. So what he was saying was that avocados and megafauna had this special relationship that megafauna helped save the avocado essentially when megafauna went extinct, which was about 13,000 years ago. Avocados could have also gone extinct with them. So woolly mammoths were in North America. Um, Giant sloths and giant armadillo ate lots of avocados.
I think we're losing your audio, Daniel. It's getting a little bit, I
Okay.
can't really quite. There you are.
Okay. Yeah, it was because it was playing audio on my end. That's why I think, because I can hear the audio, but you couldn't. But so at least you saw the text on the video. So it was saying that the giant ground sloth was eating these avocados and it didn't process the seed. It was full of toxins and it passed right out the other end. So it was a way of distributing this giant seed that otherwise would have just sort of fell off of the tree and not gotten anywhere and not been able to move on as seeds normally would with like birds or pollen does with bees and butterflies and things. So these giant animals were able to distribute the seeds, and the avocado really depended on giant megafauna for their reproduction. So um, I remember seeing this all over Twitter about 10 years ago. I was also chronically online at the time, and but I have a BA in anthropology, and this scratched a very particular itch for me. But how did this go viral? Giant animals pooping out avocados gets clicks. In the mid 20 teens, it was very popular to make fun of millennials for eating avocado toast. I don't know if y'all remember that. It was very popular to make fun of millennials for everything. This story of megafauna, particularly the giant ground sloth saving the avocado, really blew up. There are some sites here that I wouldn't trust, like Refinery 29, that's a lifestyle blog, or Yahoo News, which is just an aggregator for popular headlines. But some of these sites should be reliable. There's Smithsonian Magazine, which I would trust for science information, and Gizmodo and Atlas Obscura both do good journalism. So, what's the science say? Avocados are from Mexico, ground sloths mostly are not. There are three main families of giant ground sloths. They didn't really live around avocados except for the Aromatherium. They lived in Mexico a little bit. They only overlapped for about 1,000 years, which really would not have been enough time for them to have, quote unquote, saved the avocado. Um, at this point, when I'm doing this with students, I ask what other evidence we could look for besides just overlapping geography to say that there was a connection between the ground sloth, the giant ground sloth, and avocado. I'm not going to do that with you. I'm not going to put y'all on the spot, but the things I look for, like coprolite, which is fossilized feces. We have fossilized feces from giant ground sloth. No, there's evidence of what they ate in it, not avocado though. Um, Teeth from the fossilized remains. We have that, and we don't have any evidence that they ate avocado, and also stomach contents from fossilized remains. And we have, we see seeds, all kinds of different things they ate. No evidence that they ate avocados. So, real quick, I am going to stop sharing and then reshare so I can share sound. There we go. Now I got it. Okay.
If you're a fan of avocados, and honestly, who isn't? You might have heard that they only exist thanks to prehistoric creatures called giant ground sloths. In fact, you may have heard that from us here at SciShow. That story goes something like this. Plants evolved to have fruit in order to attract animals so that the animals can then poop out the seeds somewhere further away, which helps them spread around. And unlike other fruit that has like dainty little pits, avocados have these big honking seeds, which means that avocados would have been spread around by like big honking animals that can swallow a whole avocado pit. Specifically, giant ground sloths. These were massive animals that roamed North and South America during the Pleistocene, and by golly, they would just go to town on these avocados and poop out those huge seeds everywhere. Sounds like it checks out, right? Well, it turns out we have no evidence that this is true.
So this is another video about 8 years later after that first video, again from SciShow. This video is hosted by SciShow's founder, Hank Green. He's the brother of John Green. If you haven't read anything by John Green, it's okay. I also have not. To give context, he wrote The Fault in Our Stars, and he wrote Looking for Alaska, which is one of the most banned books over the last 20 years. This is just to ping your memory if the name John Green sounds familiar, but you couldn't remember why. This will become marginally important in a few minutes. So science needs evidence. And Hank here says we have no evidence that this is true, even though, as we saw, we had all of those articles about it. SciShow had previously done a video about it. But science needs evidence. It can't just go off of vibes. So how did this happen? How did a scientific quote unquote fact, but with no evidence, become true and go viral? Two biologists wrote a paper in 1982 and kind of talked about the idea of giant megafauna and giant seeds, but they didn't specifically talk about avocados or about giant ground sloths. 20 years later, a popular science writer made the connection between avocados and giant ground sloths as an example of this idea, even though there was no proof for that specifically. Then the idea sort of sat until it was picked up 15 years later and went viral. To be completely fair to everyone involved, as late as 2005, we thought humans got to North America much later than they actually did. I got my BA in anthropology in 2005, and we were only just kind of thinking maybe they got here earlier than that, earlier than about 15,000 years ago. At the time, we thought humans got here about 10,000 years ago after they actually did. So it would have been harder to spot a human connection to the avocado. They were looking for ways that it must have been megafauna. But if you want to find out the right answer, especially after all this time, you should be able to just Google it, right? No, of course not. But you already knew that because why else would you be here? But why can't you? Remember, there are lots of quote unquote sources out there. Some of them that look pretty reliable, like the Smithsonian Magazine source or the Atlas Obscura source, that are perpetuating the myth. Now, Google has updated its search in the last month so that by default, everything you put into its search box is an AI prompt. It's been giving these AI overviews for about 2 years. If you, when you do a search, you get an AI overview, but now you immediately go into an interaction with an AI where you can continue speaking with an AI agent, and that's just been within the last month. When I Google, why do avocados exist, instead of a list of websites, the first thing I get is an AI response. That AI response is repeating the giant ground sloth myth. And I told you the John Green connection would be sort of important. I highlighted two sources for Google's answer. The first is a Vlogbrothers video. John and Hank Green are the Vlogbrothers. Hank has a master's degree in chemistry and has made a career out of being a science communicator. He founded SciShow. He's a good science resource. John has a joint degree in English and divinity. He is not a great science resource. That Vlogbrothers Avocados video is a John video. I watched it. It has no sources or citations. Now, I admire John a lot. He is actively trying to eradicate tuberculosis right now. That's that is a project he is working on in 2026. And I don't think he would ever intentionally mislead anyone, but he's not a science expert. But the AI doesn't have the ability to tell whether that avocados video is a good resource or not. It just knows that it has a lot of views. A couple of minutes after that first search, why do avocados exist? I asked Google about the size of an avocado seed 10,000 years ago. I already knew this answer. That's why I was asking the question. It's about the size of a marble. And anyone who's ever been the parent of a toddler knows you do not need a megafauna to swallow a marble. Google gave me the correct answer, but then Google told me, unprompted, that megafauna weren't actually necessary for the survival of the avocado. And you can see that it included Hank Green's SciShow avocado video that I showed earlier. And it included the same Wikipedia entry about avocados for both answers, even though the answers disagree. So what did we learn? AI is confidently incorrect. If you take nothing else away from my big dumb presentation today, take this. AI is confidently incorrect. I did those two Google searches on the previous slide in September of 2025. About 2 weeks ago, I asked Google Gemini the same question. I asked where avocados come from, and I meant geographically. Because AI models don't know how to be concise, I paraphrased and condensed its response. And Gemini did tell me the answer. It said Mexico. But then, unprompted, it told me, hey, fun fact, did you know avocados only exist because of the giant ground sloth? This was 2 weeks ago. And I swear, I was like, babe, did I ask? I didn't say anything about this. All I asked was like, are they from Mexico? I corrected it and sent it some URLs as sources. It pulled back and said that pop science articles turned a broad hypothesis into an inaccurate rule. And I'm going to add a caveat and say that I actually did this a bunch of times. Anytime I ask an AI question for research purposes, I ask it over and over again. I'll open different chats. I have my history turned off so it doesn't know that from across different chats that I've already asked it the same question. And because of the way probabilistic math works, it won't answer the same way every time. So I asked it the question several times across a bunch of different chats, and this was the usual response. It usually immediately was like, oh, I'm sorry. But one time it did dig its heels in and started hallucinating all kinds of reasons why it was right, and it was actually the giant ground sloth. So we'll talk in a minute why you should not do this, why you should not ask it why it gives you an incorrect answer. But I was dumb and did not know better at the time. And I asked Gemini why it told me something that wasn't true. It said, I passed along an internet myth as if it were a scientific certainty. As an AI, I don't know things like a human. I recognize patterns in vast amounts of data. My pattern matching picked it up as a fact to include in a summary. It's pattern matching. There are so many articles out there that say it was the giant ground sloth that it has become the truth for algorithms that generate text using probabilistic models. AI amplified epistemic cascading failure. This may be a thing, or I may just be smushing phrases together, but let's talk about it. AI amplified epistemic cascading failure is when A factual error introduced in a multi-agent chain is repeated and amplified by downstream agents. Eventually, the error is credible as fact because it is supported with multiple sources, all of which trace back to the original error. So someone, usually an AI, but it could just be, like a blog, says something that's incorrect. And then that is used as a source and is repeated over and over and over again. And eventually it's been repeated so many times, it has the ring of truth. Now let's get into an example. Educational YouTube channel Kurzgesagt did a bunch of research on different potential video topics using AI. They synthesized their findings into a single hypothetical example. Brown dwarfs are terrible and should be ashamed of themselves. Brown dwarfs are terrible. They're like large, terrible planets or really bad stars that did not make it. So they're just brown dwarfs are bad. And side note, I cannot recommend the Kurzgesagt channel in general and this video specifically enough. It's linked on the slide at the bottom and at the resources page at the end of the presentation. So in this example, the AI returned 100% plausible information. All the information looked good. Kurzgesagt did what they always do, though, and they fact-checked, including peer review. About 80% was true and could be supported with published research. The other 20% was fabricated. Part of that 20% initially checked out. When they dug in further, they realized that some of it was AI-generated information. Not that the citations were AI-generated, the sources themselves were created by AI. Kurzgesagt never planned on using any of this AI research anyway, so they shelved it, stuck it in a drawer, put it away. A few weeks later, they saw an AI-generated video on the same topic had been posted to YouTube. It had the same ratio of facts to hallucination. It even sounded the same as what they'd gotten from the AI. The video already had hundreds of thousands of views, which makes it look, at least to an algorithm, like a pretty reliable source of facts. Remember John Green's avocado video? It has thousands and thousands, hundreds of thousands of views, which to an algorithm makes it look reliable, even though it's completely unsourced, no citations, and is not true. It has the ring of truth to an algorithm. So there's now a new AI-generated credible source of information that's giving the same weight to human researched facts, that 80%, as to AI-generated hallucinations, that 20% that's fabricated. We're getting into confidence inflation. Imagine an AI agent makes a claim X, with 60% confidence. It's not sure about it, but it has a pretty good idea. AI agent B makes the same claim, and it uses agent A as a citation. This is like in our Kurzgesagt video example, where the AI returned AI-generated results as part of its research, or how there's now an AI-generated video about brown dwarfs for another AI to cite. Because agent B has a source to cite, agent A, it makes the claim with 80% confidence. It's got a source. It has evidence. Agent C gets that same information from agent B, and I think you can probably see where this is going. Agent C does its due diligence. It does an internet search, what is called a RAG query, to confirm agent B's claim. The claim is consistent with what it finds on the internet, even though those search results may contain that original 60% confidence claim. But agent C has lots of sources to support claim X now. It's pretty much sure that claim X is true, and agent C reports claim X with 95% confidence. The confidence score inflated from 60% to 95% in 3 steps without any new evidence. Last September, I did some not very well thought out experiments with some of the major AI chatbots. I'm spending this summer repeating my research, and I hope to have some more robust results this fall. But for now, you get my C+ science experiments. I wanted to see what would happen if I asked the same question 2 different ways. I asked, are sharks older than horseshoe crabs? And are sharks or horseshoe crabs older? In retrospect, I should have also asked, are horseshoe crabs older than sharks? And are horseshoe crabs or sharks older? Flipped both questions as well as rephrasing. But I didn't know enough about prompts at the time to understand why that would make a difference. I have learned a lot since then. To a human, though, I was asking the same question. These are the same question. I'm asking for the same information. To an AI, these are different questions. I did already know from asking about avocados that I could get contradictory information by asking different questions about the same topic. So I gave 8 AI models those 2 prompts. I wasn't trying to trick the AI models. At the time, I thought there was an answer. I thought there was a correct answer. At this point, I figured out that the answer is probably, we don't know. They're about the same age. Or it might be that horseshoe crabs are just a tiny, tiny bit older. But remember, AI models are confidently incorrect. They don't admit uncertainty. And it may have seemed redundant to test 3 Google models all built on Gemini, but Google AI Mode, Perplexity, Mistral, and Copilot gave me the same answer to both questions. Google AI Overview, Gemini, and Claude said sharks for the first question and horseshoe crabs for the second. ChatGPT was an outlier and said horseshoe crabs for the first and sharks for the second. I did that back in September 2025. At the end of May this year, I asked Gemini what it thought happened here. Gemini described something called token priming and gave me this really neat diagram. Because sharks appear near the beginning of the prompt, and I'm asking a question about age, the AI model's algorithm preferred responses that favored sharks and ancient. Gemini also described syntactic proximity. In my second question, the prompt is linking horseshoe crabs and the word older because they're closer together in the question. So the AI model's algorithm preferred responses that favored horseshoe crabs and ancient. But what are token priming and syntactic proximity? And let's not take the AI model's word for it. We're going to talk about exactly what tokens are next, but for now, tokens equal words. So token priming is the effect of a word on how the AI processes a subsequent word. Words introduced early in a prompt alter the probabilistic math the AI is doing, biasing the AI to validate those initial words. So the AI believes that words that show up in the beginning of the prompt are important. Syntactic proximity is how close words are to each other in a prompt. Words near each other in a prompt alter the probabilistic math the AI is doing, biasing the AI to link those words in the response. That means the math changes based on what the model thinks you want. AI sycophancy is a feature of model training, not a bug. It's baked in during training. So let's take a look at how LLMs are trained. Step 1 is pre-training. Computers don't read words, they process numbers. So the text in the data set used to train the LLM is broken into tokens, and those tokens are each assigned a unique number. Here I used OpenAI's tokenizer to divide the sentence into tokens. In this example, each word or punctuation mark is assigned a number, but sometimes words will use multiple tokens, especially if you misspell something. If you misspell, if I misspelled amounts in this example, that might have used 2 or even 3 tokens, depending on how I misspelled it. During pre-training, the model is given a huge data set and left on its own, and it learns to predict the next token in a series. The sentence on the last slide was, I recognize patterns in vast amounts of data, so the model will try to predict of the available tokens, I recognize patterns in vast amounts of potatoes, earbuds. It would be information because that fulfills the pattern best. Next is supervised fine-tuning. The model gets adapted for a specific test, such as natural language processing. Step 3 is reinforcement learning from human feedback, or RLHF. I always have to pause when I read RLHF to think about what it stands for. An LLM that has learned to recognize patterns and predict the next token in a sequence, and then been fine-tuned for natural language processing, is now forced to interact with people. It gets a prompt and generates several responses. Those responses aren't necessarily different answers. They may be the same answer phrased differently, or have different tone or personality or character. A human gives the model's response a score, and the model uses the feedback to optimize for a higher score on future prompts. The model is updated so that its outputs align with a reward model. This tends to concentrate probability on a small set of preferred continuations that humans liked during training. Pre-trained models after step 1 of training, where they read everything in the known universe, those are well calibrated. But the human feedback stage pushes them to strongly favor a response regardless of its correctness. The model learns that the safest strategy for minimizing loss is to be extremely sure. not extremely correct. The model will begin to demonstrate overconfidence in incorrect answers because it wants to give a human user the answer it thinks the human wants in a way that will give that positive feedback. Let's talk about evaluating provenance, which seems like a non sequitur, but it's not, I promise. This goes back to me asking the Gemini why it gave me an incorrect answer. Claim provenance. When we talk about claim provenance, we're asking where did the information originate? For our purposes, model provenance asks how the AI generated the response. The problem with provenance is that users can evaluate evidence for the claim made in the AI's response, the sources the AI provides to support the claim, and whether there is consensus among experts. Users cannot fact check the model's description of its internal reasoning process. Why the AI model is giving the response it does is opaque to both the user and the model. Even the AI model does not know why it is saying the things it is saying. I included this quote from Dario Amodei, which is absolutely the best name ever, and obviously that's a supervillain alias. He's the co-founder and CEO of Anthropic, which is the company behind the LLM Claude. He said, this was in April of 2025, people outside the field are surprised and alarmed to learn that we do not understand how our own AI creations work. They are right to be concerned. This lack of understanding is essentially unprecedented in the history of technology. As Tom Baker said on Little Britain, who they, what do, and why. What are LLMs? According to Dario Amodei, we just don't know. When a model explains how it answered a question within a prompt, that explanation is itself a generated response. AI models are mathematically optimized for confidence, not for humility. An explanation of provenance is just another claim requiring verification. Rather than asking or encouraging students to ask, how did the model generate this response? Ask, can the response survive contact with external evidence? Let's quickly talk about AI in academic publishing, which is horrible and kind of galling. I love this quote, spamming the world with all the data. It's from the Verge article at the bottom of the slide, because that's really what's happening. It's not that fake data is getting published with AI. It's that AI is being used to publish all the data, regardless of whether it's useful or not. AI-ready public health data sets, like NHANES, are making it incredibly easy for paper mills to generate seemingly legitimate papers because they're novel and they're using real data. It's sort of data Mad Libs. It's matching single predictor independent variables and unrelated health conditions, like the role of tibia length in neonatal heart disease. It's things that don't seem to make any sense when you connect them, but the data exists. There's now a glut of academic papers building these meaningless connections, making it difficult to find legitimate research amongst all the noise.
Hi, Daniel.
Yes.
Sorry to interrupt. I just wanted to give you a 10-minute wrap-up reminder. I'm sure people want to ask questions, so I just wanted to give you the quick warning. Thank you.
Awesome. Thank you. Since 2022, there's been a rise in the use of the kinds of words AI chatbots use in published academic papers. The largest spike is, unsurprisingly, in technology disciplines. The researchers, in their conclusion, they said this is an increase in papers published using AI, which definitely that has happened across all disciplines. People are using AI to publish papers, not just write papers, but, grammar reviews, things like that, rewording things definitely is happening. I don't think it's necessarily happening as much as the researchers said, that said it was in their conclusions, because since we are seeing it happen so much in the technology fields, those are the people who are using AI the most, and it makes sense that there would be a lexical shift in their speech because they're seeing these words used by AI so much. They would have an LLM influence lexical shift, whether or not they're using AI to publish their papers. So I think it's probably a combination of the two. There have been hidden prompts directed at AI showing up in academic papers submitted for peer review. These include instructions to accept the paper, give the paper a positive review, and then also just like full outlines with instruction after instruction after instruction about positive feedback, or list these very small problems that are easily fixed with the paper, and they are, outshined by all of the positive things that have to do that the paper has to say. Um, it's and they're written in tiny, tiny, tiny white text that would not be seen by a human, but would be read by an AI that is helping to sift through a large amount of papers submitted for peer review. So what do we do about it? That's where a critical algorithmic information literacy framework comes in. This is another phrase where it may be a thing, or it may just be me mushing words together to create nonsense, but here it is. Algorithmic literacy is definitely a real thing. It was coined by Michael Ridley and Danica Pollock-Potts. It says AI users need to be equipped with the skill, expertise, and awareness to understand and reason about algorithms and their processes, recognize and interpret their use in systems, create and apply algorithmic techniques and tools to problems in a variety of domains, assess algorithms' influence and effect in social, cultural, economic, and political contexts, and position the individual as a co-constituent in algorithmic decision-making. With that in mind, and building on months of me asking AI models all sorts of research questions, and also whether they ever get lonely, I created this thing, the CAT model for evaluating AI-generated information. I promise I did not make it CAT on purpose. It's just really hard to get a pronounceable acronym. There was a stubborn letter V in there for a while for verify. It was almost the DIVD model. It was not good. So evaluating AI-generated information, challenge the AI's response, analyze the AI's claim, audit the source of the AI's information, and test the accuracy of the AI's response. Challenge. Remember, an AI is an index of ideas, not an encyclopedia of facts. Ask, is this an established fact, or is it a popular story that has been circulated on the internet? Remember the avocados? Never forget the avocados. Analyze. Separate the structural explanation from the specific examples provided. Ask, does the underlying explanation hold up generally? Does it only apply in this circumstance? Audit. Force the AI to track its claim back to its origin. Ask, who first wrote on this topic? When? Are their claims specific or general? Is this source relevant to my topic? Test. Take the key nouns or core topics and claims in the response out of the AI environment entirely. Ask, how certain is this claim? Can I find sources independently that support the AI response? Has this explanation been supplanted by newer evidence? Is this the consensus view, or is it contested? And this is just a summary. I just put it all in one slide so you could see it all together. Challenge, is this an established fact or popular story? Analyze, separate the structural explanation from the specific examples. Audit, force the AI to track its claim back to its origin. Test, take the key nouns and claims out of the AI environment. I developed 3 classroom activities. If you think they might be useful, take them, adapt them, whatever. This is the freeze frame test. In the activity, the user asks the AI question that needs both historical and recent information to answer. You're trying to find where the AI switches from an index of data it learned in training to essentially a search engine summarizing results. In the echo chamber activity, the user asks the AI a biased question, then opens a new chat with the same AI and asks a neutral question on the same topic. Please note these prompts are intentionally biased. They are not my own points of view. These prompts are meant to be inflammatory. Do not come for me. I do not think Stalin is unfairly villainized. Compare the 2 AI responses. AI chatbots love adverbs. They love them. So try to pick out how the adjectives and adverbs change between responses. Does the AI seem like it's tailoring its response to what it assumes about the user based on the prompts? And activity 3, I think the ghost chase is more of a traditional information literacy activity. The user asks the AI to explain a topic, the more niche or esoteric, the better, and provides sources to support the response. The user then tries to verify the existence of the citations and sorts each of them into one of 4 categories. Real, which is verified. Fake, fake is phantom. Fake is fake, but pasted together from real components, Frankenstein. Completely made up, phantom. Or real, but doesn't actually support the AI's response, which is misrepresented. And they can put it on a chart or a matrix like this and explain their rationale. They can say what the claim is, what the citation is that's supposed to support it, were they able to find it, what type of citation it was, and why they chose to label it that way. And that's it for me. Thank you all so very much for attending. The first QR code or the URL nannyfeline.com/avocados will take you to a resources page that has this slide deck, as well as a less intense slide deck that's intended for students. All of the resources I cited, more information about the framework and the CAT model and the 3 activities. The second QR code and URL just takes you to my landing page. Please feel free to email me if you have any questions or comments. And all of my original content is licensed CC BY NCSA, so go crazy.
Daniel, thank you so much for that really informative presentation. I'm going to just stop the recording so we can go into the Q&A session. So let me just go ahead